Took an archaeology class, and we spent a lot of time on studying ways to date things. One technique I remember was using the location of an object to date it, like how deep it was buried.
That would be stratigraphy.
Stratigraphy.
Stratigraphy is used for dating portable art. When archaeologists are digging at a site, they make very careful notes about which stratum, which layer of earth they find things in. And you know, the general rule is that the oldest layers are at the lowest level. But this only works if the site hasn't been touched and the layers are intact. A problem with this dating method is that an object could have been carried around, used for several generations before it was discarded. So it might be much older than the layer or even the site where it was found. The stratification technique gives us the minimum age of an object, which isn't necessarily its true age. Tom, in your archaeology class, did you talk about radiocarbon dating?
Yeah, we did. That had to do with chemical analysis. There's something to do with measuring the amount of radiocarbon that's left in organic stuff. Because we know how fast radiocarbon decays, we can figure out the age of the organic material.
The key word there is organic. Is art made of organic material?
Well, you said the lady with the hood was carved out of ivory. That's organic.
Absolutely. Any other examples?
Well, when they did those cave drawings, didn't they use like charcoal or maybe colors, dyes made from plants?
Fortunately, they did, at least some of the time. So it turns out that radiocarbon dating works for a lot of prehistoric art. But again, there's a problem. This technique destroys what it analyzes. So you have to chip off bits of the object for testing. Obviously, we're reluctant to do that in some cases. And apart from that, there's another problem. The date tells you the age of the material, say a bone or a tree. The object is made from, but not the date when the artist actually created it. So with radiocarbon dating, we get the maximum possible age for the object, but it could be younger. Okay, let's say our scientific analysis has produced an age range. Can we narrow it down?
Could we look for similar styles or motifs? You know, try to find things common to one time period.
We do that all the time. And when we see similarities in pieces of art, we assume some connection in time or place. But is it possible that we could be imposing our own values on that analysis?
I'm sorry, I don't get your point.
Well, we have all kinds of preconceived ideas about how artistic styles develop. For example, a lot of people think the presence of details demonstrates that the work was done by a more sophisticated artist, while a lack of detail suggests a primitive style. But trends in art in the last century or so certainly challenge that idea. Don't get me wrong, though. Analyzing the styles of prehistoric artifacts can help dating them. But we need to be careful with the idea that artistic development occurs in a straight line, from simple to complex representations.
What you're saying is, I get the feeling that this is like a legal process, like building a legal case. The more pieces of evidence we have, the closer we get to the truth.
Great analogy. And now you can see why we don't have an exact date for our sculpture, The Lady with the Hood.
What is the talk mainly about? According to the professor, when might stratigraphy provide misleading information about a portable object? What are two disadvantages of radiocarbon dating? What is the professor's opinion about the practice of dating a piece of art by analyzing its artistic style? How does the woman summarize the professor's main point in the talk? Listen again to part of the lecture, then answer the question.
Why don't we know the exact date when this head was made?
That's a fair question. We're talking about prehistory here. So obviously, the artists didn't put a signature or a date on anything they did.
Why does the professor say this?
So obviously, the artists didn't put a signature or a date on anything they did.
Listen to part of a lecture in an environmental science class.
Okay, so we've been talking about theories that deal with the effects of human activity on the climate. But today I'd like to talk a little bit about other theories that can explain variations in climate. And one of the best known is called the Milankovitch hypothesis. Now, what the Milankovitch hypothesis is about, it says that variations in Earth's movements, specifically in its orbit around the sun, these variations lead to differences in the amount of solar energy that reaches Earth. And it's these differences in the amount of energy that's reaching Earth from the sun. It's what causes variations in Earth's climate. Okay, a lot of people think of Earth's orbit around the sun as being perfectly circular, as smooth and as regular as, say, the way the hands move on a well-made watch. But it just doesn't work that way. You're probably aware that the Earth's orbit around the sun, it's not shaped like a perfect circle. It's more of an oval. It's elliptical. But the shape of this orbit isn't consistent. It varies over time, over a period of about 100,000 years. Sometimes it's a little more circular. Sometimes it's more elliptical. And when Earth's orbit is more elliptical, Earth is actually closer to the sun during part of the year, which makes Earth, and in particular the northern hemisphere, warmer. And why is that important? Well, because most of the planet's glaciers are in the northern hemisphere. And if it gets too warm, then glaciers will stop forming. And we already talked about how that affects Earth's overall temperature. The second movement involved in the hypothesis has to do with axial tilt, the tilt of Earth's axis, that imaginary pole that runs through the center of the Earth. And depending on the angle it tilts at, the seasons can be more or less severe. It makes winters cooler and summers warmer, or what some might say it's doing now, it makes summers less hot and, more importantly, the winters less cold, which, just like what I mentioned before, can also prevent glaciers from forming or cause them to melt. There's a third movement the hypothesis covers called precession. Precession basically is the change in the direction of Earth's axis of rotation. And it would take me a million years to explain even just the basics of this movement, as precession is quite complex. And all these details are way beyond our scope.